Hey guys, welcome back to another Swift programming logic tutorial, and in this tutorial I'm going to be talking about recursive functions, what they are and how to use them. So recursive functions are basically just functions which call themselves while they're running, and these can actually be really useful for things where you need to delete all items in a list with this, and the list is ordered or something, or other things. But yeah, they can be very useful in certain situations, and yeah, so I'm going to be showing you guys how to use them in Swift with just an easy demo. But one thing you need to know about them is that you need to kind of get into a new sort of way of thinking when you're using them. When you're writing normal functions, you're just thinking about that one thread or like one function call, but when you write recursive functions you need to think about how it would work if this function was going to be repeated like 100 or 1,000 times, because recursive functions can sometimes end up happening exponentially if you're not careful. So yeah, you just need to be thinking a little differently. But yeah, so let's just write a recursive function which will count down from the number you start with. So count down from number you start with until you hit a specified number. So basically let's just call this count down, and we're going to have a parameter called current number, and this will be all typed in, and we're also going to have a parameter called stop at, and this is also going to be in. So yeah, basically what we're going to do is we're going to be passed in a number. So if in the did load, let's just invoke this function. Let's start at like 5, and let's say we want it to stop at 0. So first what we want to do is we want to print the current number, and then what we're going to do is we're going to check whether the current number is equal to stop at, and if it is, we're going to do nothing. So this should actually be if current number is not equal to stop at. Then if this current number is not yet at the stop at, then we actually want to invoke this function again. So we'll do count down current number -1, and we'll keep the stop at the same. So there. So now if I run this, you'll see that this function is actually going to get called multiple times until the current number reaches the stop at, and then it's going to stop. So we'll just run this, and we should see a list of numbers counted down from 5. Okay, and let's just wait for the console to pop up. Okay, and you can see that it counts down from 5 until 0, because that's where we specified it to stop at. So yeah, this is just a basic recursive function which just calculates, this counts down from 5, and then using this logic you can see that this invokes again when it's not equal to stop at, so it goes again, and then when it finally reaches stop at, we just don't do anything, so the function just stops. So using the same logic we can actually implement a factorial function which should be the same thing. So let's just call this factorial, and let's just call it current number again. And notice how I'm saying current number instead of number. I mean, we could just say number, but I think current number makes more sense, because as we pass it in, you see that it's the current number instead of just the number we started with. So yeah, that's quite useful. And let's invoke this function. So factorial just means if you were to do 5 factorial, then that would just mean wait, let's just write 5 factorial is actually written like this, is equal to 5 times 4 times 3 times 2 times 1, and that's actually equal to 120, I believe. So yeah, let me just make sure of that. 3 times 2 6, 4 times, yeah. So yeah, all we're going to do is basically use the same logic, but instead of, we're also going to have a current number and also another thing called the current result. You don't have to put current in front of this, but I just like to use it as it makes it make more sense, if you know what I mean. And current result, we'll just leave this as int. So when we specify current result, we actually want to just leave it as 1, so that when we multiply them out, it's not going to affect anything. So now what we can do is we can do current result, we can do let new result is equal to current result multiplied by current number. Then we need to check whether the number is not equal to stop at. So if current number is not equal to, and we don't actually have a stop at parameter, but for factorial you always stop at 1, so we'll just do 1. And now we'll just do, if current number is not equal to stop at, we will just invoke this function again. So we'll just do factorial current number, we'll set this to current number minus 1, and current result, we'll set this to new result. And then if it has reached it, then we will just print new result. So let's see what this says for us, and you can see we get 120. And what I'll do here is I'll actually print underneath here current number and new result, so that you can see the steps. So if I go here, you see we start at the current number, which is 5, so we start at 5 and the new result is also 5. Since we start at 1 and then we've multiplied 5 by 1, which gives us 5, then the current number becomes 4 and the current result becomes 20, as the previous one was 5 times, this is 5 times by 4, which gives us 20. Then becomes 3, and 20 times 3 is equal to 60, becomes 2 times 60 is equal to 120, and then 1 finally. I mean, we don't even need the 1 anymore. Like, if we just leave it as 2, it will do the same function, since 1 doesn't affect the thing at all. But we'll leave it as 1 just to keep it simple, so people can actually understand. But yeah, this is how you use recursive functions. You can see they just call themselves in their own function. Thanks for watching, and make sure you always have a way of breaking out with this recursive function, because it's really easy to loop forever in these kind of functions. So yeah, thanks for watching, and I'll see you guys in a future tutorial. Bye!